Morning class. For today's short lecture, we have on sun, solar system, planets, and your major moons. This will be a short lecture. It will be part of your physical geography. So let us start now. So we have the formation of solar system, nuclear disk model. So it was an early theory. So we have nebular hypothesis. It's by Kent and Laplace. It's assumed solar system formed from a giant cloud nebula. Got the nebula idea right, but had flawed assumptions. Then we have close encounter hypothesis by Chamberlain and Moulton. Wandering star pulled material from the sun, which later formed planets. Then we have revised nebular hypothesis, Smith and Weizsäcker. Sun was surrounded by nebula of gas and dust. Planets formed through collision and clumping. Modern theories we have Big Bang theory and nuclear disk model. So from here the important points are the nuclear disk model, nebula hypothesis. It's by Kant and Laplace. It assumes solar system formed from a giant cloud. Then we have close encounter hypothesis by Chamberlain and Moulton. Wandering star pulled material from the sun. Then we have revised nebular hypothesis by Schmidt and Weizsäcker. Sun was surrounded by nebula of gas and dust. In modern theory, we have the Big Bang theory. Universe began with a massive expansion and nuclear disk model by Neo-Laplacian. Focuses specifically on the solar system. Nebula collapses about 5.6 billion years ago. Sun and planet formed roughly 4.6 billion years ago. We have early theories like nebular hypothesis, close encounter hypothesis, revised nebular hypothesis, and the modern are Big Bang and nuclear disk model. So we have how the planets form. We have accretion, dust particles collided and clumped together. Planet, large border for a few kilometers across. Protoplanets, planet continue to grow, attracting more material. Planets, protoplanets become large enough to sweep up remaining debris. Planet type, inner planets and outer planets. Terrestrial and gas. Leftover rocks that didn't become planets. Iron catastrophe, planetary differential. Early Earth, a hot uniform ball of iron catastrophe. Radioactive decay and leftover heat melt Earth's iron. Planetary differentiation. Heavy elements and lighter materials. So how planets formed? We have accretion, planetesimals, protoplanets, planets. So planet types we have inner planets, terrestrial, outer planets, gas and ice giants. So iron catastrophe and planetary differentiation. Early Earth, a hot uniform ball of rock. Iron catastrophe, radioactive decay and leftover heat melt Earth's iron. And planetary differentiation, heavy elements and lighter materials. So now we have some ideas of the solar system. We have the heliocentric model, ecliptic plane, orbits, ancient understanding of the Earth, your spherical Earth, and Kepler's law of planetary motion. Heliocentric model, Nicholas Copernicus pioneered the idea that Earth and planets around the sun. Ecliptic plane, most objects orbiting the sun, including the planets, lie close to a flat plane called the ecliptic. Orbits, planets nearly circular orbits around the sun. Comets, asteroid, Kuiper belt objects, often highly elliptical. So ancient understanding, spherical Earth, Pythagoras and Aristotle. Kepler's law of planetary motion. The orbit of a planet is an eclipse with the sun at one of the two foci. A line segment joining a planet and the sun sweeps out equal areas during equal intervals of time. The square of the orbital period of a planet is proportional to the cube of the semi-major axis of its orbit. We have distances and light years. So light year is a measure of distance and not time. Planets from around 4.6 billion years ago. So these are the important light year. Light travels at 3 lakh kilometer per second. So planets in a solar system. We have inner planets terrestrial and outer planets gas giants. So location closer to the sun before the asteroid belt, rocky and metallic, and then outer planets are beyond the asteroid belt. Rotation, most planets rotate counterclockwise like the sun. So this is a comparison between inner and outer planets. So just go through this once. This was your short class on solar system, the formation. So first we learned what were the early theories, the modern theories. We saw what are outer planets, what are Jovian planets, what are gas planets, what are terrestrial planets. So through this was your short lecture. Thank you, class.